back and we're going to calculate the Fourier series this time. So similar to what we did in the last video. So just another example, but with a different function now. So let's do, oops, let me zoom in so you can see. So I'm going to do my basically y series, which is going to be a naught divided by 2 plus total of table of a sub n, and then I'm going to do times cosine 2 times pi n times t divided by my period t, and then I'm going to do plus b sub n times sine of cosine of, what am I talking about? 2 times pi times n times t divided by t. I'm going to slash dot n goes to, I'm going to go n goes from I, and we're going to do from table from I goes from 1 to 10, the first 10 harmonics total. That's it. So nice, simple, straightforward, easy, hopefully. So let's go ahead and plot this guy. So I'm going to do my plot. I'm going to take a lot of these functions, but I'm going to delete a couple of them. I'm going to do, instead of list plot, I'm just going to do regular plot. I'm going to do my y series. I'm going to change this from blue. I'm going to do this thickness. Change it to 0.5. 5. I'm going to get rid of that filling. And let's see. Whoops. Let's see. Y, because I didn't give it any bounds. That's why, Josh, come on. 0 to 3. And let's see. Signal. Actually, I can plot from 0 to 6. Let's zoom out and let's see what we look like. So, looks pretty similar. I can make this a little bit nicer if I now go ahead and do, I'm going to do my original signal. So, orig equals show plot of my y1 from t goes from 0 to 1. Plot style, red. We do the same thing now, except I'm going to do for 2, 3, and 4, just overlay this. And again, you want to do this for your lab report, or not your lab report, your problem sets. So I'm just going to do this, just so I could get an idea of if my signals approximate well. So this is my y2, and this is my y3. And there we go. Those are just my functions. I'm going to show them all. Actually, let's go ahead and plot. I'm going to do plot range. Actually, it doesn't matter. So I'm going to do this as my f series y, fsy. So I'm going to show fsy, and then my y. What did I name that variable? Original. And you can see captures it pretty well. So this is just the original signal here. So if I increase my number of harmonics in my function here, I'm going to hide these. This is not going to change. This y series can change. So if I go to 100, and then let me get this here. And then right here, much better approximation. So, but if I only do 2 harmonics, or 3 harmonics, since I just typed that, and here we go. That's it. So you can see how, again, your approximator signal changes as the number of harmonics increases. So that's it for continuous Fourier transforms. So in the next video, we're going to get into lecture 7, discrete Fourier transforms. So dealing with real data, and we're going to see some cool concepts like signal aliasing and spectral leakage. So more on that next time. See you in the next video. Thanks. Bye.